All right. Notice there's not any dates on this thing yet. I need force completion. I'm not going to. It can be saved and resumed later. You're going to get at least 3 attempts. There's going to be all kinds of directions on this thing. I haven't put those in yet. That's a reminder to me to do that before I launch this thing for you all. So let's go ahead and begin. Let's take a look at what this looks like, so you're not afraid. So you at least get a look at it before we get started. Okay. All right. Okay. All these are pretty straightforward. Okay, so far so good. All right, so far so good. This is poorly worded. I just noticed I need to fix this. It of course is this one, but I need to fix question 7 because that's very poorly worded. And I hope you enjoyed the Tennessee tuxedo video. That's what I grew up watching when I was about 8 or 9 years old. That's how I got hooked on science. All right. Anyway, did you notice that Mr. Whoopi had an iPad? We didn't know about those back then. All right. All right. So far, so good. Did I tell you what an impulse was? It's the average force times the change in time is equal to an impulse. Is equal to the change of momentum. That's the impulse. So right there is the question. Answer 10. Okay. Okay, so now let's determine the force on an NFL kick. Let's kind of work through this, okay? All right. So, or the next 4 questions, I got to turn off my phone. I got friends I think watching the tournament, the basketball tournament. So, here we go. All right. So, the next what is the velocity of the ball when it's being held? When it's just being held, how fast is it going? Right. Now, they told us that the speed of an average by place kicker is equal to 80 miles. We need to convert that to meters per second. I'm going to show you how to do that right now. And we'll finish this problem. Then I'll do one more video to finish up this pre-lab, okay? All right, so here we go. So how to convert 80 miles an hour to some meters per second. All right. I'll just did we do this in the other lab? I can't remember if we did or not. Now there's the long drawn out way we can do it. We can go 80 miles in 1 hour times 1 hour, which is made up of 3,600 seconds because I need seconds down below. And then the hours cancel. The hours units cancel. Times there's 1,609 meters in 1 mile. So the miles cancel. And I wind up with 80 times 1,609 divided by 3,600. Okay? Which is 35.76 meters per second. Okay, well that's all fine and good, but I tell you what, you can just go ahead whenever you need to convert miles per hour to meters per second, just take what these guys are already divided, what they already are, okay, and go 1,609 divided by 3,600, and it's equals 0.447. That's our conversion factor. So if you ever, like 100 miles per hour times 0.447 is equal to 44.7 meters per second. That's how you do it. Multiply whenever you need to convert miles per hour into meters per second, miles per hour into meters per second, multiplied by 0.447. You're golden. All right, let's go see what else they got here. Calculate the acceleration of the ball while it is being kicked. Okay. Well, how long is 0.43 seconds? Whoa, wait a second. I'm missing something. I've got to update this. I got to add the question about the time of the kick. In other words, if the mass of the ball is 0.4, we can do 15, but we can't do 14. So we found the answer. We found the answer for 13, but we can't do question 14. I am so sorry. I'm glad we went through this. Can't do question 14 until I know the time that the actual kick took place. So I'm going to have to watch that movie one more time out here.